Alright, today's little topic, should you choose to, let's go here. Today is, did you ever see any of these problems here? Probably not. No, let's do this one. No, let's do this one. Let's do this one. Yeah, today's little topic is what's called similar triangles. And maybe you've seen this on your maps test or whatever it is. So jot this down. Similar triangles. Which simply means this. When you have similar triangles, their sides are all proportional. So you are going to use a ratio box. And let me put it up for you right at the very beginning so you can see it. When you do that, here is what it will look like. Your ratio box is going to look like this. I would strongly suggest labeling it. You've got the smaller shape, or the smaller triangle, and you've got the big triangle, and then you've got the two things that you're comparing. And in this case, you talk about the height and shadow. So here's the height, and here's the shadow. And those things are proportional. They make equal fractions or ratios. So when you read something like this problem here, where it says, whoever wants to know the height of a flagpole, she stands a meter stick in a vertical position. Here's your meter stick in a vertical position. Okay, and the shadow it casts is this right here, 120 centimeters. At the same time, the shadow of a flagpole is 30 meters. How tall is the flagpole? Well, you can't see it here, but anytime they talk about shadows and how tall things are, you are going to use this. And you're going to do similar triangles. And you need to sketch those triangles out to make the teacher happy so you don't continue to get a whole bunch of homework all the time. So I recommend taking this. You're going to draw this triangle over here as best you can. This is 100 centimeters over 120 centimeters. And the big triangle is the flagpole, which the problem with flagpoles is it's really hard to get to the top when you measure them, so this is a good way to try to figure it out. There's my triangle there. And then you just need to fill in the pieces here. What was the height of the small triangle? Oh, that's right here. It's 100 centimeters. What is the shadow of the small triangle? Not rocket science, but it is 120 centimeters. What's the height of the big triangle? How tall is it from here to here, children? Somebody? Huh? Somebody was saying, we don't know? We don't know. That's X. And then what is the shadow, this distance from here to here? 30 meters. These were centimeters. In this case, ladies and gentlemen, as long as these measurements are consistent with each other, okay, you don't need to change them into like measurements. This will end up just being however many meters there. Okay? So, to go from 120 to 30, can I do that or not? What is it? Yeah, sure you can. Might have to divide, but you can still divide. What? 120 divided by what? 80? Right. I'm going to divide this by 4. I get 30. So then I divide this by 4. What do you get here? 25. The flagpole is 25 meters tall. Which makes sense. Could a flagpole be 25 meters tall? Sure, why not? And you're going to say, hey, let's do that again. Let's do another one. Let me say that. Let's do letter B, because letter B is kind of a goofy one. Is that okay? A lot of people get confused on this, but it's not as hard if you just take the time to sketch it out. First thing I'm probably going to do is make my ratio box. Well, no, first thing I'm gonna do is, I guess, sketch up my triangles here. See the dude there holding the ruler upright at arm's length, at arm's distance? And they gave you the arm's distance, which is 24 inches. Ronnie aligned the bottom of the ruler with the mark on the utility pole. That was about 5 feet above the ground. Ooh. Right here, see that? Just go line that up there. He saw that the top of the pole aligned with the 6-inch mark on the ruler. He took 40 long strides to reach the pole. If each stride was about 1 yard, 30 feet, then the top of the pole is about how many feet high? Now looking at that, most of you are dazed and confused, correct? But if you just pick it apart and you can dimension, find two triangles and get their dimensions, you're going to be able to figure this out. What two triangles do you have? You've got this one right here, this little guy right here. Let's draw that. Here's Mr. Little Triangle. That's the little guy. What are the dimensions of the little guy? Well, you got to look at the problem here. How far, we know how high it is, right? That is 6 inches. What's this distance from here to here? It's said in the problem. The person sitting out there holding out the ruler, that far. Brooke, it's, right, that's the length of that person's arm. So there is your little triangle. Halfway home we are. Okay. The big triangle, which is, it's actually part of, the little triangle is incorporated in it. Here's my big triangle. Let's draw it. Here's my big triangle. I need at least one of these two dimensions to be able to figure out the other one. Which one do I get? Do I know how far it is from here to here? Sure, because it said this person took 40 long strides, and each stride is 3 feet. So if you take 40 strides and each one is 3, Alex, it's 120 feet. Yeah, this is 120 feet. Now the thing you have to be careful with it at the end, if they ask you the height of the pole, whatever you get for this measurement, because he was looking 5 feet above it, you're going to have to add 5 feet onto it because he doesn't. That triangle doesn't include that little bottom piece there. So right there are your two triangles, people. You just have to do the little table we talked about doing. Remember we had small and we had big, and it doesn't matter which one you put where. You've got, to talk about shadow, what two things are we comparing there? You got the small and the big, and it doesn't really matter how you label that other side there. It is, and if you want to go bottom, if you want to go height to width or length or the bottom, height to base would probably work. What's the height of the small triangle? 6. What's the base of the small triangle? 24. What's the height of the big triangle? X. What's the base of the big triangle? 120. Does this one work out? 24. And you feel free, since this is a fraction, people, you're just doing this. 6 over 24 equals what number over 120? You can reduce this if you like. You could make this 1/4. It's going to be the same ratio. 4 times what is 120? 30. So 1 times 30 is 30. And again, knowing 30 is not your answer because 30 is only this chunk from here to here. You still have to add the 5 onto it. If you want how high the pole is, you'd have to take the 30 plus the 5 to give you 35 feet. Get that right? I did get that up. Alex.
Could you use Venn diagram dribbles for this or?
You can't, because you're not looking for the hypotenuse of this right here. Okay, if you were, you could, if you wanted to find out what that was, sure you'd use the Pythagorean theorem, but we're not. These are just equal ratios and equal proportions, as it would be. Again, the key though is, which many of you are going to struggle with, is just sketching out the information you got and making those two triangles. Some of you just don't like to do that, but neither here nor